Hey guys, we're going to get started on lesson 3.3. So let me present my screen and we'll go ahead and get started. Okay, so for this lesson, we're actually going to learn the converse, right? When you flip the hypothesis and the conclusion of the theorems we learned in the last lesson. All right, so we have the corresponding angle theorem, the alternate interior angle converse, the alternate exterior angle converse, the consecutive interior angles converse. All right, so I'll read these. I'll show you the shorthand that we're going to use for our proofs, and then we'll jump into some problems. Okay, so the consecutive angle, or corresponding angle converse says that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So in a proof, we would say corresponding angles congruent implies parallel lines. So if you remember the other day, we said the opposite. We said because we know the lines are parallel, that implies that the corresponding angles are congruent. Now we're going to be starting with this information. We're going to be given that a pair of corresponding angles are congruent, and that's going to allow us to conclude that the lines are parallel. All right, so the alternate interior angle converse similarly says that if we know that our alternate interior angles are congruent, then we're going to be able to conclude that implies that the lines are parallel lines. Okay, and move down. So the next one, again, says if we know that alternate exterior angles are congruent, then that allows us to conclude that our lines are parallel. That implies parallel lines. All right, and the last one before we get to a new theorem, consecutive interior angles theorem. Remember, that's the same thing as same side interior, which is what I refer to them as. All right, this theorem says that if same side interior angles are supplementary, that implies parallel lines. All right. And then this last theorem here says that if two lines are parallel to the same line, then they are parallel to each other. Okay, so you can see over here it says if line P is parallel to Q, and if line Q is parallel to R, then we're allowed to conclude that P is parallel to R. So if two lines are parallel, then all three lines are parallel, basically, okay? All right, so that leads us to our examples. It says in exercises 1 and 2, find the value of x that makes m and n parallel. Explain your reasoning. Okay, so what would have to be true about this angle here? I'll put an arc on it. This angle here and this angle here in order for the lines to be parallel. Well, if those two angles were congruent, if they were congruent corresponding angles, then my lines would be parallel. So that's what I'm going to write. If my corresponding angles were congruent, that would imply parallel lines. So in order for the lines to be parallel, they have to be congruent. So I'm going to set them equal to each other. I have to erase because I can't even see what that number is. Okay. So I'm going to say that 8x plus 55 has to equal 95. Those angles have to be equal to each other in order for the lines to be parallel. All right, subtract 55 from both sides, and you're going to get 8x equals 40. Divide both sides by 8, and you get x is equal to 5. All right. Okay, next one. What must be true about this angle here and this angle here in order for the lines to be parallel? they would have to be congruent alternate exterior angles. So that's what I'm going to write. I'm going to actually write up here just to give myself more room. So if my alternate exterior angles, if they're congruent, that, oops, let me erase that. Alternate, oh, I'm saying one thing and writing another thing. Let's try that again. Alternate exterior angles congruent. If my alternate exterior angles are congruent, that implies parallel lines. So I'm going to set them equal to each other. 200 minus 2x equals 130. I'm going to subtract 200 from both sides. So I get negative 2x is equal to negative 70. Divide both sides by a negative 2 and you get x is equal to a positive 35. Okay. All right, let me scroll down. Okay, so it says in exercises 3 to 6, decide whether there's enough information to prove that M is parallel to N. If so, state the theorem that you would use. All right, so do I know whether or not M and N are parallel based on the markings? What kind of angles are these based on their location? They're corresponding angles. And when corresponding angles are congruent, that means the lines are parallel. All right, so M is parallel to N, and my reason would be corresponding angles congruent implies parallel lines. All right, what do you think about number 4? Is this enough information to prove the lines are parallel? No, these are vertical angles, right? And vertical angles are congruent, but vertical angles do not imply parallel lines. So not enough info. Not enough info. Another thing to remember is that when you're looking for an angle pair, like if you come over here, this angle and this angle have one side in common. One line makes up a side of both angles. This line here, the transversal, right? So if there is no transversal in common of the two angles, you're not going to be able to say anything about the lines, all right? So that's one thing to look for as you're looking at these examples, okay? All right, let me scroll down so we can do the last two on this page. All right, so again, vertical angles. Do vertical angles imply parallel lines? Nope. I'm just going to say nope, not enough information. What about this example here? Can we try to maybe envision that this isn't here for a second? What kind of angles are these? They are alternate exterior angles. So I can say that M is parallel to N, and the reason would be alternate exterior angles congruent implies parallel lines. Okay. All right, let me scroll down. Okay, this next worksheet, I am only going to do a few because I'm probably going to have you do some of these problems for an assignment, whether it's in class or homework. I'm not sure yet, but we'll figure that out. But I want you to understand the approach to these problems, so I'm going to demonstrate. All right, it says identify the segments that must be parallel based on the given information. We're going to be highlighting, tracing, so if you're able to print this out, it would be helpful. If not, you'll just have to kind of sketch it on your own. So first thing I'm going to do is I'm going to mark the information that's given. You're told that angle 2 is congruent to angle 9. So to the best of my ability, I'm going to put an arc on angle 2 and an arc on angle 9. Then I'm going to look for what line, I'm going to call them line even though they're segments, what line do they have in common? What line forms both angle 9 and angle 2? Hopefully you see it right here. It's FB. I'm going to trace over that. That is your transversal. If there is no common line, you can pretty much stop the problem. All right. And then what other line makes up angle 2? It's this line here, angle AB. And then what other line makes up angle 9? This line here, FC. So now if you can just, I know sometimes it's hard, if your eyes can just focus on the highlighted black and the red, what kind of angles are 2 and 9? They're alternate interior. And when alternate interior angles are congruent, what do you know about the lines AB and FC? You know that AB is parallel to FC. So that's what we're going to say. We're going to say AB is parallel to FC. And I can either I'll put a segment bar over top because they really are segments in this diagram. Segment AB is parallel to segment FC. All right, let's look at another one. Let's look at number 3. So you're told, this one's a little bit different. You're told that angle 1 is equal to angle 8, which is equal to 90 degrees. So you can put like a right angle box on each of those if you want, or just mark them congruent. I'll put a right angle box if I can. So here's my right angle box for angle 1. And then for angle 8, okay. Now first identify what line makes up both angle 1, so the lines are here, and angle 8, here and here. Which line do they have in common? This side here, right? This is part of angle 1. It makes up one of the sides of angle 1. And then if I continue, it also makes up the side of angle 8. So I'm gonna try to trace that. Okay. And then the other side of angle 1 is this right here. The other side of angle 8 is this right here. So again, try to only focus on the angles that are marked in the highlighted black segments. What kind of angles are these? I know they're right angles or 90-degree angles, but I'm talking like alternate interior, alternate exterior, corresponding same side interior. They are corresponding angles. And when corresponding angles are congruent, what do you know about the lines? You know they're parallel. So again, AB is parallel to FC. AB is parallel to FC. Okay, let's do another one. Let's do number 5. Show you something else. So number 5, you're told that angle 2 and angle 5 are congruent, all right? What are the sides of angle 2? Here and here. What are the sides of angle 5? Here and here. Do the two angles share a common side? They don't, right? They don't share a common side at all. So not enough info. This is an example where if they don't share a common side, that means there's no transversal. So they're not going to have any of those angle relationships we're talking about. Let's look at number 11. So number 11, you're told that angle 5 plus 6, we're looking at this entire angle here, is equal to 9 plus 10, this entire angle here. So let's highlight the sides of the angle. So for 9 and 10, I'm looking here and here. For 5 and 6, I'm looking here and here. Notice how I traced over a certain line twice. This line right here was part of both angles. Now I'm just kind of tracing over and extending. So try to have your eyes just focus on the transversal and the two lines. What kind of angles are these? They're alternate interior angles. And when alternate interior angles are congruent, the lines are parallel. And I'm going to just name the segment from top to bottom. So I'm going to say AE is parallel to BD. If you just name part of it, that would be correct as well. but just for consistency, so we can hopefully all have the same answers, AE is parallel to BD. Okay. And I think that's all I'll do. We'll leave the rest up for you to try for that page at least. All right, let's keep on moving down though. All right, I'm gonna leave this top section for you for later, but I do wanna illustrate the bottom part, okay? So it says, find the values of X and Y that make AC parallel to DF and AE parallel to BF, okay? So in order for AE to be parallel to BF, what would have to be true about this angle and this angle? They'd have to be same side interior supplementary angles. So one equation you could write is that 5y minus 7 plus 4x minus 18 is equal to 180, right? These would be this angle here and this angle right here. In order for these lines to be parallel, they would have to be same side interior angles, which are supplementary. So that's one equation. Now, as you're looking at that equation, if you're thinking, well, I can't solve that because there's both x's and y's, you are correct. So we have to look for another relationship, okay? So if this line was parallel to this one, what would have to be true about this angle and this one? They'd have to be same side interior, and no, sorry, not same side, alternate interior angles, which would have to be congruent. So you can set them equal to each other. 3x plus 2 is equal to 4x minus 18. So the first equation that I set up, I wasn't going to be able to solve because there's both x and y, but now I have a second equation that can be solved because there's just an x. So let's subtract the 3x from both sides. Right, so then I have 1x plus 2 is equal to negative 18. And then, that's not right. What did I miss here? 3x plus 2 minus, moved it to the wrong side. Oh my goodness, guys. I think I've been doing math way too long today. Boop, boop, boop. Let's try that again. I wrote the wrong thing underneath. I don't know if you guys caught that. It's 4x minus 18. Okay, so let's subtract the 3x from both sides. And when I do so, I have a 1x over here. I wrote down the wrong side of the equation. All right, and then add 18 to both sides. So then I have 20 is equal to x. All right, so now that you know that x is equal to 20, I'm going to use this equation and plug that x value in to solve for y. So let me erase all this. Okay, so I have 5y minus 7 plus 4 times 20 minus 18 equals 180. All right, so I'm going to have 5y minus 7 plus 80 minus 18 equals 180. I'm going to combine all my like terms, which is going to give me 5y plus 55 equals 180. Subtract 55 from both sides, so I have 5y equals 125. Divide both sides by 5, and you get y is equal to 25. All right. So you had to set up two equations in order to solve for both x and y. Okay? And I'll leave the second problem for you to try at a different time. All right. So let me jump back over here. That is going to be it for this part of lesson, what number was that? 3.3. We'll do the proofs in the next time. Bye.